This is on page 96 on combinations. Now, suppose there are 5 numbered cards, 1, 2, 3, 4, 5. You're required to select 4 cards at a time. Now, selecting 4 cards at a time, now you'll notice that permutations, there's a repetition. Combination, no repetition. Combinations, there's no repetition as well. It's no repetition, but in permutations the order is important. In combinations the order is not important. Whether you select card 4 before 3, it doesn't really matter. Now the question is, how many combinations could you choose? Now I've worked this out for you, and say we do 1, 2, 3, 4. You got 1, 2, 3, 5. Then you notice 1, 2, 3 has been more or less exhausted. Then you can go to 1, 2, 4, 5, 1, 3, 4, 5, where you're keeping 3 of them constant. Or then you can get 2, 3, 4, 5. So if we take the problem on combinations, you're looking at, we're taking 5, it's 5 combination 4. Now 5 combination 4, you got getting the answer 5. So now how can we use the principle of factorial to get our answer? So you're looking at NCR, which is a number of ways, and that will give you the 5 combination 4. Now if we just treat this as 5 factorial divided by 5 minus 4 factorial, then we've got a problem still, because then it comes down to permutations. Then it needs to go like this, times 4 factorial. So that's the combination. And then we now, when we say NCR, it's n factorial divided by n minus r factorial times r factorial. So those are a combination, that's the principle. And we will just take a problem. .3 on this page is page 96, and it says a committee of 6 people are chosen. So the total you want is 6, are chosen from 6 parent component. So the parent component as 6, and then the student component as 8. Now from the parent component we want to choose 4 parents, and from the student component you want to choose 2. So the number of ways of choosing from the parent component, number of ways for the parent component will be 6 combination 4. And the number of ways of choosing from the student component is going to be 8 combination 2. And then the total number of ways, total will be 6 combination 4 times 8 combination 2, and that would have given you 420. This is problem number 38, which is on page 107. How many ordered pairs xy of positive integers x and y such that xy plus 5x xy plus 5x plus 5y is equal to 2005, and we want to know how many positive integers. Let's say we want to make x the subject of the formula here. So you got xy plus 5x is equal to minus 5y plus 2005. Then you got x into y plus 5 is equal to minus 5y plus 2005. Dividing, you got x is equal to minus 5y plus 2005 divided by y plus 5. So let's try to create a situation here where you got minus 5 into y plus 5. So that will be minus 5y minus 25. So I've added a minus 25, so I need to add the 25 on that. It'll become 2030 all over y plus 5. We've used this several times before, and now we can divide each one. So I'll get minus 5, the y's cancel off, but then I've also got plus 2030 over y plus 5. Now the question is how many pairs of positive integers I've got. So if I had to actually multiply this by, factorize the numerator by the way, so I will get 2 times 5 times 7 times 29 all divided by y plus 5. Now remember, my y, the lowest value y can have is 1, because they're talking about positive integers. Y will not be equal to 0. Now if y was equal to 0, obviously we got some answers there as well. Now if I take this part here, 2 times 5 times 7 times 29, they're all prime factors, and the number of divisors they will have is 2 to the power 4, which is 16. So we could very easily say, it'll have 16 divisors, and all we need to do is to start to say the 16 divisors, and it just works out just like that. But remember, x must also be positive as well. Now the logic here is I'm trying to just work out my own strategy for this problem. Now obviously we can't make y plus 5 equal to 2 on its own, so it will exclude one of the factors there, so 2 comes out on its own. Then I cannot take y plus 5 to be equal to 5, which means that y will become 0, and then so in other words 5 has to come out completely. Then can I take y plus 5 to be 7? If that's the case, then what will be, then I can replace y by 2, 7, and then it will work out perfectly. That's not a problem. So 7 is not a problem. So 2 and 5 individually are problems. Then the other one is this. Supposing I take 2 and 5, 2 times 5 is 10, and I make y plus 5 equal to 10, then y is equal to 5. Now we also have another problem here, is where let's assume I took y plus 5 to equal to the entire number there. Then I'll get 1 minus 5, and I've got a problem. So I can't take that set there. 2 times 5 times 7 times 29 as a set. Then can I take 29 times 7 times 5? I will have a problem as well because I'll end up with 2. So I can't do that. So in other words, I can take 2 times. I can't take 7 times 29 times 5. And I can't take 7 times 29 times 2. So I can't take 1, 2, 3, 4, 5. So which leaves me with 11 as the answer. The information that I'm supplying you with is the binomial theorem and the binomial expansion. Actually, we did prove the theorem, and the binomial expansion there, you will notice that we use Pascal's triangle for the coefficients. And let's take a plus b cubed. That is a cubed plus 3a squared b plus 3ab squared plus b cubed. And now we are saying that this is a very useful tool, but obviously you will learn more about this. You can learn more about this at school if they are doing it, but it's very, very useful to do probability problems. Now let's go on to normal distribution. The normal distribution curve is where data, the data is captured, and you will find that the average, this curve here is used as a probability curve, where when we say normal distribution, it assumes that the population is of a type where the expected results are there. Now, there are several other cases that you can use, several other distributions which I've indicated, but we use the normal distribution curve. Now, at the middle of this curve, which is at the center, you get the mean, and then you get the deviations from the mean itself. Now, if you look at the mean and the first deviation, it's called the first standard deviation, and that should capture 68% of the population. And then if you look at the second, the second set of deviation, where you get 2 standard deviations away from the mean, you should get 95%. And then if you look at the third deviation, you should get 99.7% of the scores. Now, you will now know to look at we want to just give you a better idea of how this works, because the way the curriculum is designed, you don't have an excellent understanding of what this is all about. Now, I'm going to take the case where washing powder is sold in boxes which have a mass which is normally distributed with a mean of 200 grams and a standard deviation of 2 grams. Now the question is, calculate the probability that a randomly selected box will have a mass less than 197 grams. Now what we do is we use a table which is called a Z table. Now, in order to use the Z table, what we do is we say we have Z is equal to C minus U all over the standard deviation. So now if you take, you're looking at 197 minus the mean, minus the mean which is given as 200 all over the standard deviation which is given as 2, and then you get minus 1 comma 5. Now the table that I gave in this one here gives you all the scores Z values which are less than. So we've got the probability that X is less than 197. In other words, some of the boxes have got less than the what they supposed to have had, and so then this translates to probability that Z is less than minus 1 comma 5. Now when you read from the table, you will get an answer which is 0,0658, which is in 4 digits, and that translates to 6,58%. So the probability that a randomly selected box will have less than 197 grams is actually 6,58%. Then let's assume you got more than 201 grams. Here you got 200 more. So Z is equal to C minus U all over standard deviation, and this gives you 0,5. Now remember, this X is greater than 201, and then Z is greater than 0,5. Now our problem is this Z table is values less than, but the sum of all the probabilities under the normal distribution curve will give you 1. So what we do now strategically, it says 1 minus the probability that it's less than 0,5, and 1 minus, when you read the table, it says 0,6915, and that gives you 30,85%. Now then, assuming now you want to find out how many of the boxes lie between 198,5 and that, so what you do, you find Z1, which is 198,5 minus that, and you get minus 0,75, and then you got Z2, and that gives you 199, which is minus 0,25. So what you've got actually is the probability that X lies, then the probability is that Z lies between the two values. But remember, the Z is always less than. So we've got to find Z less than minus 0,25, which has a higher value, and minus the Z value less than minus 0,75, and you subtract that, it is 17,47%. Now if you apply your minds very, very carefully to this and work out problems, you can actually capture a huge population of students, and we can actually find out, if we're given the standard deviation and the mean, we can find out what population, if it's normally distributed, what percentage, or what is the probability that we've got A's, and then we can, if we know the actual population, and we can multiply it out and get the number of A's. So this is a huge advantage, and we'll move on. Scatter plots, regression. Now this is page 100, and we're looking at sample size and statistical inference. But basically, when we're dealing with even normal distribution curve, etc., in most instances they use a sample as well. Now, a scatter plot demonstrates the relationship between two variables, bivariate data. This relationship is called the correlation. Now we're talking about two variables for one item. Now, assuming you are doing, you are investigating the performance of a group of learners in mathematics and science. Now you can't take one group for maths and compare them with a group for science. It's not going to work. So the same group's marks for maths and science will have to be worked out. Now, the closer the data points, the higher the correlation. So you can work out, look at the first one, it's perfect positive correlation, like y is equal to x. and the next one is a perfect negative correlation. So if we go down, you will look at the next one, which is a correlation which is a high positive correlation, and then you've got the next one, which is high negative correlation, and the last one where you'll find all those points are scattered, no correlation, etc. Now remember, when you're saying negative correlation, now it means that when one one of it is going up, then the other one has the opposite effect, more or less. Now look at this problem here, where we're studying the data table for the performance of 10 learners in mathematics and physical science. At this stage, I want to mention very, very clearly that in order for us to arrive at valid results in statistics, you need a minimum of 30 in the data set. So therefore, when you are writing an examination, and when you have less than 30 in the data set, even whether it is at school level or the national senior certificate level, you're not going to get valid results from it. Now let's look at this here. What we're going to do is, now we want to we want to use calculator here, and just for the sake of completeness of this work. So when you go into mode in your calculator, if you're using the FX991 ES Plus or the Nitei RK108, that's what I'm using, and you can go into mode 3, which is statistics, and then you've got a choice, one variable or the other one is the two variables, which is number 2, which is A plus BX. Now A plus BX, and you'll remember how it is written as A plus BX. A is the constant and B is the BX, B is the coefficient of X. So what you will do now is you'll select number 2 and then enter the X and Y values. So as long as you know 1, X, 85, 75. So you can enter all the X values up to 10. 85 equals 73 equals 45, 68, 91, 53, 72, 44, 68, 71 equals, and then you can go on to the other side and start with 1 again. Go move your cursor right to the top and start with 75 equals 64 equals under the Y column. And once you have done all that, then you press the AC key, and don't get scared that it may have eliminated all what you have done. And then you press, once you've done that, then you press Shift 1. And you press Shift 1, you'll see a whole host of things coming up, and then you've got 5 regression. And once you've got 5 regression for this particular problem, you will see that you have the A value. So your A value, you press that and you get your A value, which is minus 7 comma minus your A value giving you minus 7,099, and then you can go again Shift 1 regression, and then you will get your B value, which will give you 0,969, and then we'll just for timing also get our R. Go Shift 1 regression, and then you get R which is a correlation, which is equal to 0,973, and then you can now write down the equation as Y is equal to minus 7,099 plus Bx, which is 0,969 x. Now why I wrote to so many decimal digits, 3 decimal digits, because sometimes you get very, very high values and you can lose its impact when you do that. Now it says draw the scatter graph. The scatter graph is already drawn for you. It's in the part of the work there. Describe the nature of the correlation between the two variables and comment on the correlation. The correlation itself is R is equal to 0,973. And the nature of the 0,973 very clinically is very high positive. So what does it translates to? It means that there's a very high positive correlation between mathematics and physical science. So a student who is doing well in maths is expected to do very well in physical science as well, and vice versa. It would work both ways. Then they want you to now determine the line of best fit or regression line, which I've given you as y is equal to minus 7,099 plus 0,969x, and then calculate, that's determine the line of best fit or regression line, calculate the correlation which we've done, and I mean we've done that from the scatter plot we were reading, but we actually did this and we worked backwards. Yeah. Now the question is, let's assume there was a student who wrote the mathematics paper and didn't write the physical science paper, and this student who wrote the maths paper had 88%. So that will be minus 7,099 plus 0,969, and this person at 88. So when you take this out, you will see 0.969 times your 88 minus 7,099, and this person would have got 78% for physical science. And then it means that is a very true mark for that child. And now that concludes the topic on probability and all that. I think I've covered the most salient parts of this topic. You can complete the rest of the work that's in the book, and it will also prepare you more than adequately for your National Senior Certificate exams.